Hi, welcome back to Missing Chemistry. This is gram to gram lesson number 2. Let's look at the first problem. What mass of AlOH3 is produced if 22.7 grams of NaOH is consumed? Okay, so the first thing we have to look at is we need to know the mass, formula mass of AlOH3. Alright, so we have to calculate that first, it looks like. So let's go ahead and set that up. So we have Al, we have one of those. We have 3 oxygens, and of course we have 3 hydrogens. So this is going to be 26.98. And if you're wondering where I get these numbers from, I'm getting them from the periodic table. Alright, so now we multiply all this and add them all up, and we get this to equal 78.01 grams per mole. Okay, so now let's go ahead and do the problem now that we have that. So let's see here. Oh, we also need one more thing. We need to know the molar mass of NaOH. Alright, so let's see here. So we have Na, we have one of those at 22.99. Oxygen, one of those at 16.00. And hydrogen, one of those at 1.01. Well, when we add this all up, that's going to give me 40.00 grams per mole. Alright, now, space looks like it's getting a bit tight here, so we're going to do our best. Let's go ahead and do this. So we go 22.7 grams of NaOH. By the way, we're going from my grams to my moles to their grams. That's the flow pattern. Alright, so we're going to try this. So far, so good. Now to do the mole ratio. The mole ratio is going to be, let's see here, 6 moles on the bottom. And we're going to have, of course, 2 moles on the top. And again, space looks a bit tight, but I think we're going to be able to make it. Put 1 mole of that on the bottom, AlOH, because we're converting into their grams, and we know that the molar mass of AlOH is going to be, of course, 78.01 grams. Okay. I think we're going to be able to squeeze this one in. Alright, so now we're just going to put that equal down there. So grams cancel grams, moles cancel moles. See how that works? And when we do the math, we're going to get 14.76 grams of AlOH3. Pretty snarly, huh? Okay, let's look at the next one. The next one, guys, is going to be looking at the problem where we have what mass of oxygen reacts when 84.9 grams of iron is consumed. Okay, so this one's going to be a little bit easier as far as spacing goes, because we don't have to figure out, the molar mass of a compound. We just have to look on the periodic table and we can see these masses. So we have, and again, our flow is going to be my grams to my moles to their grams. So we start off with 84.9 grams of iron. Okay, we want to convert this into moles of iron. See that? Divided by iron's molar mass. Now, iron's molar mass is going to be 55.85. So it's going to be 55.85 grams per mole. And then where do we get that? We get that off the periodic table. We want to do the mole ratio. We get the mole ratio from the balanced equation. So 4 moles of iron are going to go on the bottom because we want to cancel those out. And we want to know the moles of oxygen, so we got 3 moles of O2 on top. All right. But we want this to be in mass, so we have to get rid of the moles of oxygen. We're going to do next. And since oxygen is diatomic, it's going to be 32.00 grams of O2. Not just going to be 1 oxygen. 16 grams, it's going to be 32 grams because it's diatomic. We cancel out our common units. And our answer is going to be roughly, let's double check our figures here. So we get 84.9 divided by 55.85 equals times 3 divided by 4 times 32. And I get 36.48. So we get 36.48 grams of O2. And that's it. So you guys be snarly, and we'll see you back here at Moosing Chemistry.